talked about still in your notes yesterday was the formula for compound interest. Now, there's about 5 of you in here that actually write this down when you take a form quiz. Anybody know it? Formula for compound interest? Hence the reason the shuffling. Because you don't actually know it unless it's in a certain position on the form quiz. The amount after time passes was the principal times 1 plus R over N to the NT. I've written these things down so many times in my life, and that's the big deal. I've written them so many times in my life that I legitimately do not think. I don't. Whatever part of my head controls this hand does it. Now, that makes any sense to you or not, but there's zero effort applied in following that formula. Where A is the amount earned or owed, depending on the setup of the problem. B is the initial investment, the principal. R is the rate of interest as a decimal. N is the number of times interest is compounded yearly, and T is the number of years that pass. And below is your common types of compounding. How many days per year? 365. How many months in a year? 12. How many quarters? 4. Semi-annually, what's that mean? 2, twice per year. Semi is a half, so 2 halves per year. How about yearly? 1. And these are your N values. You gotta scan text and look for that. Those are your N values. And that is the formula that actually rules your life. Most of you guys are going to borrow money one day. That's the formula. That's what they use. Banker, credit card, doesn't matter. Loan shark, probably not. But any legal institution will be using the formula of compound interest. All right, your great-great-grandmother left you $4,000 in what's called a money market account that earns, in 1956, that earns 6.3% interest compounded monthly. You get to access it this year after you graduate from high school. Sorry, you get to access this account after graduating high school. Everybody in here is a junior, so let's assume next year. Andy, are you a 10th grader?
No.
Okay. Didn't know. How rich will you be? Well, let's scan the text. What's the principal? 4,000. All right. What else do we need to know? We need to know the rate as a decimal. As a decimal. It is 6.3%. What is that as a decimal? I swear we did this yesterday. Maybe not. 0.063, shift twice. We did this yesterday. All right, what else do we need to know? We need to know N. Right there. It's compounded monthly. So 12. 12. And I reckon we need to know the time. So if you graduate next year, what year is it? 2024. There's a big if there. But if you graduate next year, it's 2024, and when did Grandma throw this money in the account? What's the difference between 2024 and 1956? 68. All right. Now again, what's that formula for compound interest? All right, keep writing it. What is it? Read it, write it, say it. A sub T. 1 plus R over N, NT. Plug crap in, kids, and then you get to push buttons. We've got everything labeled. I know a lot of kids don't like to write, but and a lot of kids won't even write this. They'll just go straight to the calculator. The more you write, the more likely you are to remember this stuff. That's why I'm literally on autopilot all day. I've written it so many times. Or keep doing you. You see your grades just as well as I do. Synergy should be up to date for y'all, with the exception of maybe your graphing quizzes. let's see, what are we saying was 12? The next one would be 12 times 68. Before you push any buttons, how much money do you think you got? A bunch? 6 figures, 7 figures, 5 figures? No guess? It's not as much as I thought it would be when I made the problem up this morning.
I wouldn't say.
That's weird. I don't know why that's in there. Nothing else. And again, you should push the buttons. A lot in almost every class, there's kids who don't get it because, and you need to see that you don't push the buttons right. Any class where everybody's playing along, pushing the buttons like they should be, there's always one or two kids who don't get the right answer. I couldn't see what I actually wrote. Did I type it in right? It's a chunk of change. $286,886.90. 286. 868. 90 cents. You know, some people in this world have grandparents and parents that do that for them. Called trust funds. I am not that lucky. I hope you are. But if you were, you'd probably not have when you're in high school. I suspect of it. All right. I would be surprised if there were some kids with some trust funds in the school. With that much cash in it?
Yeah, I started it when
Mm,
I don't know how much mom has in it. I started it when I was born.
that was nice of them.
It was great. My great grandma.
Is it going to be worth that much?
Well, he owned like the post office, so.
Okay. I'm surprised. I probably should have set up one for my kids, but they're going to struggle just like I did.
How nice. Very kind and thoughtful.
This is exponential decay. What do you get if you take half of 2? 1. What do you get if you take half of 1? It's just your fractions. You get a half. What do you get if you take half of a half? Then 8, 16, 32nd, 64th, 128th, 256, 512, blah, blah, blah. Does it ever hit 0? No, it doesn't. What happens is you start off with a big value, flat line. Remember yesterday? Yesterday was, oh, hold on. Yeah, yesterday was this, right? Well, that's today. High, low. I'm not going to bore you with the plotting of those weird looking points. The big deal is that you don't actually cross the origin, and you just kind of flatline right there on that. That's the big deal. My flatlining was horrible. You redo my flatlining.
This graph is way better than this. You can actually see.
Yeah, it's a bigger grid, which is a problem on the next example. The problem with big grids, sometimes you don't have enough room.
I can see my line this year.
Yeah, again, but there's a problem on the next page because the grid's too western. It's only a 5x5 grid. What's the domain of that thing? Range. Low Y value. 0. With parentheses because you can never take half of something, a third or an eighth of something and hit 0. It's impossible. But the essential 0 might as well be called 0, but it's not actually. So it's hitting 0 on the right. What's it doing on the left? Goes to infinity. Now, let's talk about that. We never actually get to be 0. What's the equation of that line that you never get to be? Y equals 0, the horizontal asymptote. Horizontal line that is generally speaking not crossed. All right, there's what that mom looks like. You actually learned 2 more moms. You did. You learned exponential growth and you learned exponential decay. So the next graphing quiz, there will be 2 more moms. Should be easy points. All right, graph the equations in the form y is a times b raised to the x minus h plus k, which we've talked about all year. So just look at this thing, 4 times a half raised to the x minus 2 plus 4. What does the x minus 2 mean to you? Right 2. One kid said, but it's not in parentheses. It doesn't matter. You can wrap it in a set of parentheses if you want. It's all by itself in the exponential space, isn't it? The same thing. What does the plus 4 mean to you? Up 4. Andy, did you ever talk about this with the BYU coursework? Transformation shifts?
No, but I did stuff like this in.
Okay, good. Good. She has been all over the country when it comes to schooling, from what I hear. So we go right 2, and we go up 4. That is the problem with a big grid like that. If you look back at Mom, did Mom have a point where the axis is cross? She didn't. She had something above it, maybe below it, depending on transformations. But what you do gain is you gain an x value. What's the x value on that vertical line? 2. And that's your centering point. There's your centering point. I wish we could use the concept of initial slope here with these, but you can't. It doesn't work for these. Sorry, it doesn't. But what's something before 2? What's something after 2? 3. And if you have x's, plug them in, right? Andy, have you ever used a storage feature on a calculator? I don't know. You learn to do this. Anybody else don't know how to do this? Do it. I'm going to take a 1. If I look to the left of 1, I'll see this key that says STO. It's for store. Then I'm going to hit the X key, right next to the alpha. X. Then we'll press enter. Then I'm going to type in the equation. The equation was 4 parentheses 1 over 2. Rooftop, arrowing up. You want to arrow up? The exponential key. That's the exponential key. That's how I got up here. And that was x minus 2. I have to arrow down. I didn't forget what's there because I can't see it. Plus 4. Should get a 12. All right, now that's 12. And you'll want to pay attention to this. This is why I like storage feature. Hit 2, store x again. 2, store x. Press enter. And then press your up arrows until the previous thing was highlighted. I want to highlight that. Press enter. Enter one last time. Turns an 8. I'll do this again for you, Tanner. Watch, Tanner.
I got it, it's 8, right?
But did you actually highlight it?
Yeah.
Okay. Now I'm taking 3, storing to x. Ah, Tanner, you should have paid attention a long time ago.
Oh, that's right.
No, you didn't. 6. Values are doing what's expected. They're starting high and getting smaller, aren't they? Now, the reason I said this is a bad grid is because can you go up to 12?
No.
No, it's way up there, isn't it?
And I guess if the X was 4, then
2 and 8 would be about right here.
5.
3 is a 6. It should be somewhere up here. Yeah, you'd actually have to go bigger, but it doesn't really matter. Do you know what it's supposed to look like? Don't you? It's supposed to start high and curve flat. That's what matters. All that really matters. And the only thing I care to talk about on this, well, I guess I need to. What's the domain? Positive thing. Range. Now, domain is always inherited from parents. Always. Whatever mom's domain is, a child's domain is. Range changes. What's the low Y value? 4. Because you're getting really close to 4. What's the high Y value? Infinity. That dashed line, that's your horizontal asymptote. What's its equation? 4. Y is 4 anywhere on that line. Plus, just like yesterday, last number. What is? Don't forget to say Y equals. You just say 4, that's nothing. It's got to be Y equals.
Wait, would 4 not be a bracket?
On
On the range?
no, kids. God, why can't I smack you upside the head? Can you actually get to 4? Could mom get to 0? Kid can't get to 4.
I don't know why I had a,
I don't either.
I had a bracket on 0.
I'm gonna go with drugs. What I'm gonna say. This is modeling with exponential decay. The formula for growth was a sub t is the principal times 1 plus r to the t. Since it's decay, what do you think is different? Subtraction. Amount after time passes is the principal times 1 minus the rate of decay raised to the exponent of t. And the big thing in here is just like it was yesterday. Look for that every. Always be on the lookout for every. Always be on the lookout for that. Because if you see it, you have to actually change it from t into t over something. So be on the lookout for it. Other than that, it's the same lesson as yesterday. It really is. We just have a subtraction symbol. So if yesterday made sense, today will make sense. If you were still a little fuzzy, today will help. A four-wheeler costs $9,500, and its value decreases an average of 31% every 2 years, unless crackhead steals yours. True story. Write a yearly decay model for the four-wheeler. All right, so let's plug in our little formula. This is the default. You guys know what default means? What you initially think about. Sometimes you modify it just a little bit. Sometimes, a lot of times, it's more than just plugging in P and R and stuff like that. You actually have to modify T in this example. What is the principal or initial value of said four-wheeler? 9,500. 1 minus R. What's R? 0.31. Don't you write in 31%. Write 0.31. If you just write T, you're wrong. T over 2. Periods of 2 years. Now, one other thing I want you to pay attention to is this says yearly decay. That's actually not a yearly decay. It isn't, it isn't. It can be treated as such, but it really kind of isn't. To make it a true yearly model, we have how much T out there? 1. You wouldn't have T over 2, you wouldn't have half time. You have 1. So I don't know if I talked about this in your class or not yesterday, and it's the reason I'm shuffling up formulas to some degree. Somewhere on your form quiz, there is a result of x to the AB. What creates that?
8, right, that's 8.
You said the same thing again twice. It was wrong yesterday, it's wrong again today, Porter. It's x to the a to the b. X to the a times x to the b is x to the a plus. That's the one you used a lot of your freshman year. Probably didn't do much of this one. Anyways, what that says is you can take something outside and move it where? Inside. If you look at that rule from right to left, it means you can take it outside and move it inside. You just have to know that t over 2 can be viewed as 1/2 of t. That's what you have to understand. They're the same blasted thing. So let me go ahead and put this here, 9,500, 1 minus 3,100 is 69 hundredths to the 1/2, because I can move that half power in. Now it's a single T on the outside, and it is a yearly model. It is based on per year, not per 2. You see the difference? It's based on per year, not per 2. And what you should do, because that's what the state of Tennessee likes to do, is you should go ahead and figure out what 69 hundredths is to the 1/2 power. You might remember how I suggested you round. Fourth. State of Tennessee will either do 3 or 4. They'll never do something silly like 2. I haven't seen it yet anyways. 0.8307, right? There's your little formula. So I hope writing is easy, because if you can write, you can do part B. Because in part B, what do you do? Everywhere you see a T or what? Not hard. So the amount after 4 years, 200 of 4, 9,500, 0.8307 to the 4th power. By the way, you could have put a 4 there and been fine too. It wouldn't have mattered. You would have handled it just fine. And then you should push buttons just to make sure you can push buttons. And believe it or not, pushing buttons actually helps you remember your forms. Because you're using it right now. You're using the form. 45, 23, and 77 cents. Hope you got the same thing. Sadly, toys lose a lot of their value pretty quick. Part C, when is this thing worth $2,000? Where are you going to throw $2,000? Base of T. Don't be the kid who puts it in for time. I have never measured time in money. And here's one of those things you should definitely play along with if you don't know how to use a calculator. So they should definitely be on for sure. And we talked about not being able to do this yesterday, didn't we? We don't know how to do this by hand yet, do we? You will. Don't worry about that, because I do. So you will. Where do you put $2,000? Why 1? How about the other side? Why 2? I sincerely hope that whenever you don't know how to do anything, this is what you default to. This is where you go. That's something. You'd be amazed across state Tennessee how many kids don't understand how to do this. That's why we keep doing it. And all you gotta do is turn the calculator on and play along, kids. So you're in Y equals by now, and that's what you type. Go to Y equals. Type in what I have, which is what I wrote. 2000 Y1, equation Y2. I'm waiting on Andy. First day. I actually went slow with y'all on your first day. Pretty sure I did. I usually do go slow on the first day I talk about this. So I'm waiting on Andy right now. It's her first day. Zoom how? Zoom 6. Same way it's been since last year. Zoom, scroll to 6. Press enter. Why don't you see anything? You gotta look up. You literally put 2,000 Y1, which you better know is a horizontal line where Y is 2,000, or you ain't learned jack crap yet. Which means you look up above what? 2,000, window. What's a good number for Y max? Window, hit window.
I did press one.
What's a good number for Y max? 2,500, that's good, because it's more than 2,000. Anything more than 2,000 would have worked. 25,000 probably too big. Now, you don't hit zoom 6 again, what do you hit, Aniston? Graph. You played with the window. Graph.
Got boxes under
Yeah,
there.
boxes.
That's because somebody from doing homework borrowed my calculator and forgot to turn stat plots off. Because they don't listen to me. And now I have that restored you back, sorry. Anyways, we're here. Second trace what? 5. 5 for intersect. That's probably gonna be the last time I hopefully go slow on this. Anyways, is there only one intersection?
You're supposed to.
Just press enter 3 times. I don't know why I'm messing with cursors. Enter, enter, enter. There you go. About 8.4 years. What you got? Okay. We'll do one more of those just because we might have to move a different direction. We have time to do it too. We're gonna skip B. B doesn't actually matter. What's this one about? Oh, another person left you some cash. $2 million. 2009, but it's poorly managed. So it loses 32% of its value every 3 years. It sucks. You're actually gonna be pretty mad at your granddad when you see how much money you got left. Because in one of those situations, you could have been set for life, but not what he does for you. I have to wonder how he came up with $2 million anyways. All right, are we growing or decaying? That's decaying. We are losing. Now, I know it talks about money, and there's a lot of kids who every time they see money, they think compound interest formula. Does it mention compounding? So it's not compound interest. It's just straight up decay. Principal times 1 minus r to the t. That's your default. Plug into that and maybe adjust some things. Principal will be $2 million. I'll help you see that. What's the rate of decay? 0.32. Kaylee, how do you need to modify that exponent t? Yes, ma'am. Look for that keyword every, at least with how I write. That's my keyword.
It's in, third.
You don't have to actually do that. No, only if somebody asks you to rewrite it. Or maybe says which of the following is equivalent. That's the only time you have to do it. It actually does not have to be done. It's done so that the state can see if you understand how to manipulate things. And that's actually all algebra really is. Do you know how to manipulate equations? Anyways, I'm cleaning that up right here. And the deal is, how much do I receive from my great-grandfather? So I have to figure out how long this is going to take to happen. How do you figure out how many years have passed?
3 minus 9.
You can do 23 minus 9 since they're both 2000s. How many years have it?
14.
14. And everywhere you see a T? 14.
With the 23 I just because it's
2023. Right?
Yeah.
Yeah. Most people actually say 2023
Oh.
minus 2009, but you actually don't have to because those don't matter. Do they? Anyways, it's not near as much as you'd hoped, is it? It's kind of a small amount. And again, you should push those buttons to make sure you can push those buttons. Last period, 2 people got this one wrong, pushing buttons. You have to go back and see what they're doing wrong. We gotta know where those exponent keys are. There you go. So you're not set for life, are you? Truth is, you'd be a little mad about it. Because somebody probably told you got $2 million in trust fund. Nothing was said until this year. You're gonna be so disappointed. All you can do is buy a house. Poor thing. With your $330,000, $677 and 71 pennies. All right, I think there's one other thing I want to talk about. If I have time for it. It's about Dresden, Tennessee, actually. Yeah. And honestly, the only one part of this I want to do is C. All right? Because I want to play with the windows some more on our calculators. I actually just want to do the C part. So I'm going to do the setup for it. Then I hope you understand it. Population, initial population is 3,200. 1 minus 0.15 is 0.85. The exponent's t over 4. Anybody got any issues with the equation that was written? I hope it makes sense. Okay? I want to know when the population is going to be 1,400, so what piece gets replaced with 1,400? Thanks to t. And I do want to go through the calculator one more time, because we don't always look up, do we? Nope. What you're doing here is trying to look into the future of the past. That's what you're trying to do, look in the future of the past. So again, we're in y equals. What's going in y1? 1,400. y2 is the right-hand side, 3,200. 0.85. Root top through the x over 4. Now by now, you guys ought to be quicker typing on a keypad than I am at the board. You should be. It's slow at the board. A lot of y'all are already doing Zooms. Some of y'all are playing with your Windows. Good for you. And have you got all this typed in? Zoom 6 then, son. And you won't see jack crap on a Zoom 6. Why? 1,400's higher. You need to look up, what's a good Y-max value? 1,500 is a good Y-max value, something bigger than 14. And then you can hit the graph key, not the Zoom 6 key, and you're still not going to see your answer. The standard Zoom 6 only goes left 10, right 10. That's 10 years in the future. That's all it is. Don't you think you ought to go a little farther? Try 20. Try 30. Y-max was, we set our Y-max to be 1,500. How far in the future you want to go for X? 25? I'm good with that. That makes you look to the future. X max 25, hit graph, see if it's enough. It might take your time. There she is. 25 does it. You see an intersection, you have an answer. Second trace what? Second trace 5. Enter, enter, enter. Roughly 20.3 years. There's your notes, kids. Hopefully, every single one of you can start. Lex, did you play along in that last one? Did you play along in the one we just did? Good. You want to use your calculator now? Can you use your calculator now? But can okay. So, practice it. Lexi, that's huge. You can pass almost any test knowing how to be correct.
Around here, we go.
You I noticed your last test, I mean, it wasn't great, but it was one of your better ones. You're getting better.
That's not that bad.
I wasn't talking to you, I was talking to Anderson.
Still, 19 out of 36.
Okay,
Over half.
so like this